I've been making some more progress on the Cube project, and last time I was having problems where when the Cube was checking the nRF24 module for data, it would flash on and off, and so it was kind of polling that network card, and it was causing it to flicker. And I was able to solve that by getting rid of the polling and using interrupts instead. But I started to get a different idea about how to implement this, and I really changed things. It's kind of neat now. When I go and I click this button, rather than sending over a data packet that just puts the cube into a different mode, what's happening now is this Arduino here is transmitting all the data that the cube should be showing. And the program on the cube isn't changing at all. There's no logic for what it should display. It just simply displays whatever in its memory buffers for the LEDs. And so I'm just sending over the data as quickly as I possibly can from this Arduino's 2.4 gigahertz transmitter over to the cube. And it's working pretty well. It's been pretty neat because theoretically, these things can go up to 2 megabits per second, and I wanted to see how fast I could get it, just for fun. And yeah, I'll show you some of the stuff I found. So with these little network cards, there's several different libraries you can choose from, and I played around with the MRF library a while ago because it had support for ATtiny chips that you can also run Arduino code on. And a little bit more recently, the RF24 seems to be pretty popular now too, and they have updated it so that you can use it with ATtiny microcontrollers. I've played around with both of these. I wanted to show you the RF24 example that I kind of started out with for this testing of how to stream data as fast as I could. So in this example here, all I'm doing with the RF24 library is turning off the auto acknowledgement feature, setting the bit rate to be 2 megabits per second, and then down here in the loop, this is the cube side. All I'm doing is looking to see if there's any data that's come in, and then reading that data from the radio, and then incrementing the number of packets that have been counted. The data packet maximum size is 32 bytes, and that's what I've done, is made a data packet that's 32 bytes. And so then once a second, what I do is I print out how many packets times the size of the data, which is 32 bytes times 8 to give me the bits per second. And then over here on this guy, all I've done here is set up the radio in the same way, no auto acknowledgement, 2 megabits per second, and then I just simply write to the radio this chunk of data, this 32 bytes of data, and then just so I change it slightly, I just was incrementing the very first byte that's inside this data packet to increment it from 0 to 255. And so I've got these two sketches loaded, and if I go to the serial monitor, you can see it's getting about 330 bits per second. That's as fast as it's able to transfer over the data. Okay, so these two programs here are just using the nRF24 library with the cube code integrating it. So there's a couple of additional calls that I had to put in for being able to communicate with the cube, and still setting the same auto acknowledgements off and the bit rate on the radio. And then within the loop, I have to suspend the cube so that I can use the SPI bus, and then talk to the radio, get the data out of it, and then resume the cube, and then once every second just report how many packets have come in, and then make a call to actually update the cube with the data that is received. And then on the transmitting side over here, Very similar thing, just setting up the radio just like before, and then just hooking up the button so I can change what the cube is, what data is being sent over. And then in the loop here, this is just where I'm changing the cube mode if there's a button press, and then I've got some functions that I'm determining what data I should send over, and then it actually sends the data over. So for example, if we go down to do primaries, it just is updating once every 20 milliseconds. It's just updating the color of a randomly selected LED, and then it sends over all the cube data. And if I show the do runner, this one here, what it does, so this is the do runner is mode 0 and do primaries is mode 1. But do runner here, all it's doing is it loops through all of the LEDs in the cube and sets them to be off, and then it just picks one of the, it increments going through the cube, one LED at a time, turns it on to be red, and then sends that over, and then it turns off all of them, and then it sends over the next one, and then the next one. It just goes as fast as it can. This is the do runner program here in action. So it just goes as fast as it possibly can, just sending over. And so this is my my mode that kind of is the fastest bit rate that I can send over. And then I got that matrix effect one. So when I upload this and I take a look at the this number of bits per second, you can see it's still really high. You know, there's a little bit of overhead with all the additional logic, but it's able to do 250 bits per second or so in this do runner mode. If I click the button here and put it into the do primaries, it's a lot lower because I'm just not sending over as much data. I've got a delay in there of 10 milliseconds or 20 milliseconds, whatever it was. So it's just not having to send over as much data now. And if I click it again to put it into the matrix effect mode, then it's a little bit more, but still not nearly as fast as that do runner mode. So this is the current kind of state of the art for what I've got, the fastest I've been able to get it. I've got the mRF library here, and it's able to get up to 488,000 bits per second. So the mRF library is the one that I've been primarily working on because, again, I'm more familiar with its innards and how it is set up. And I was doing lots of experimentation with different bit rates and seeing how fast things were going, and all that good stuff. I even put in some optimization for how it turns the CE and CSN pins on and off, so that it does direct port manipulation instead of using digital writes, which is a little bit slower. So I did most of my time has been spent on this library. I'm sure I can get the other one just as fast, but this one is fully done with interrupts and has the same basic structure here for the cube here that's on the side, where if it has an interrupt, then it goes and it checks the radio to see what the data is that's come in. So I have to suspend the cube and figure out what caused the interrupt, and then if it was data, then come in and get the data, increment the packet count, a lot like before. Little tweaks that I found I needed to do to make it as fast as possible was to take advantage of the FIFO pipes that this has got in it. It can actually have 3 different received packets and 3 different transmitted packets in these pipes, and you can actually fill them up faster than this thing can send it. And so you have to kind of account for that with your library. And so, for instance, here when I go and I get the data out of the one of the FIFO pipes, I need to then continue to get data out of it until the receive FIFO is empty. And when I turned up the speed of this thing to 2 megabits per second and optimized things, this was absolutely required. I couldn't just grab one piece of data when an interrupt happened. I needed to actually, some more data had come in and I needed to just loop through it and keep on grabbing that data out of it. And all the while I'm having to suspend the cube from updating and then call a command that goes and updates the data that is stored for the cube and then suspending the cube again. So all that kind of slows things down, but still it's really, really fast. It was choking there for a second, but it's, this is actually now being limited just by how quickly this Arduino over here can send the data over. You just can't go faster than this, all the stuff that I'm doing on this side. So when I slow down the bit rate to 1 megabits per second that this thing is transmitting at, this does cut the speed of this, but it doesn't cut it in half. It only cuts it by like a third. It goes into like 300 bits per second, 300,000 bits per second. So anyway, that's been some of the fun that I've been doing. Trying to get streaming of data as fast as possible over to this thing. I wanted to show one more thing about how I'm sending the data over, and so let me show you the packet that I'm sending. Call it radio stream packet. So it's actually a 26 byte packet. The largest packet that you can send with this hardware is 32 bytes. And so I'm sending over this cube mode, this LED ID, and then a string of 24 bytes that I'm just calling data. And so the idea for the cube mode is where I could just send over, instead of maybe being in the streaming mode, I could send it over a mode for going to sleep, for example. And then the LED ID and the data is actually, these two combined are how I'm actually getting this data over to the particular LEDs. And it comes down to the hardware and how many bytes it takes to set the colors of each one of these LEDs on a row. So the way that the cube works is you can control the brightness of the red component of this LED with a number between 0 and 255, so 1 byte, and then the green and the blue also can be 1 byte. So each LED needs to have 3 bytes of data, and if you do an entire row, that's 12 bytes. And so based upon the limitation of being able to only have a 32 byte packet, I can send over two rows of data in that 24 byte array, and then I've got some bytes left over for that mode, and then the ID number, the LED ID number, which basically says what group of rows is it. So I made this one 0. This is LED ID 0. These 2 rows here, and then these are LED 1, and then 2, 3, all the way up to 7. So down in my update cube function here, what I do is I take a look at what LED ID came in, and I set the X and Y position of the LEDs that I should set the colors on based upon that. And then I just loop through setting the red component, the green, and the blue component from the data that came in for that particular X, Y, and Z LED over here. And it just, so this is what's happening all the time. It's just whatever data that came in, it just updates it just as fast as it can. So, so yeah, that's how I tried to be most efficient with the data packet when I was sending over the colors here.